So good morning, everyone, to today's webinar, which is Compete and Win with Data Science and AI. Today we're going to be talking about real-life examples of using data science to compete and win. We know that many of you have joined from all the other parts of the series. We'll have a quick look at some of the presenters from today. So my name is Herron. I look after product marketing, and I've also had the pleasure of architecting some of this series that you guys have joined. I joined TIBCO with the acquisition of Statistica. Statistica is a 30-plus year old advanced analytics platform with about 20,000 customers and many hundreds of thousands of data science users. I'd also like to welcome as a presenter today, Krista. Krista's a good friend of mine. We also call him the Stig of analytics, and he's based up a mountain right now in Norway. Krista is the managing director of PrecisePrediction. PrecisePrediction is a new brand from a company called Statsoft Norway. And again, Statsoft Norway have over 30 years of helping customers compete and win with advanced analytics platform. And finally, many of you will already know Heleen from part 1 and 2 of the series, but Heleen runs and manages the data science team here in TIBCO across EMEA, and we're very pleased to have Heleen joining us today. So I'll do a quick series recap. This is our agenda today, so we'll look at a quick series recap. And then I thought we'll throw a bit of fun in. It's, we're halfway through the week, it's a Wednesday, so we're going to talk about when AI loses its eye, so when artificial intelligence becomes a little less intelligent. And we'll quickly go on to the main subject for today, which is real-life stories, stories from the coalface. And Krista is going to be able to talk about some of the projects that he's been able to help some of his customers with. And I think when we were practicing for this session, we also had Krista was talking to us about a skunk work project that we've invited him to kind of share with us, and I think you'll find that very interesting. And of course, finally, Heleen will bring to life some of the tremendous work that we've been doing with our customers. We'll be looking across the globe, so we're not going to look in kind of a country level. We're going to be looking across the globe. We've got a very exciting story about how probably one of the most competitive sports in the world that now relies on data, and the data science team that Heleen manages will use TIBCO's tools for improvement. And then finally, we'll look at TIBCO community and Q&A. So as a reminder, and we'll share, you don't have to write this down now, we'll share this with you towards the end. There's a series landing page. So you can go back, and on demand you can have a look at the introduction. So this is really some best practices and some really just quick, easy ways of being able to use data science and being able to visualize that. In part 2, well, this was quite cool actually. This was the data science lab, and this we had some of TIBCO's best data scientists giving tips and tricks and a labs kind of session. I saw the numbers and the attendees that joined us for that, and it was really a highlight, and I've seen some of the questions that came back from that as well. So I know how much you enjoyed that. Let's see if we can do as well today. So the first thing I'll say is, many people ask me whether analytics is applied to a certain industry, and I give the example about electricity. We should be using analytics and data science to fuel innovation. As data becomes a commodity, we need to be doing this. We need to just as we wouldn't now move to an office that wasn't connected up and had electricity, or we wouldn't move to a factory where there was no electricity supply. We should really be seeing that application of data science and innovation across all industries. So, I'm calling a few out here, but I think that's really the key message that we'd like to make is that whatever we're doing, we need to compete and win with data science and bring that into our businesses. So here's the bit I thought would be a bit of fun. I'm not going to call all of this out. I think probably if we looked at this, if your product, maybe in the healthcare industry is where we see a danger, if products are not meeting regulations. Equally so, drilling operations. We've seen some issues around the globe and the catastrophes that can occur. But what happens if that was an algorithm? So we'll look at a couple of examples here. We won't take too long on those, but we hope that they've brightened up your morning. Would you guys pay $23 million for a book? Please have a look. I mean, this is a really interesting story, and the story behind the algorithm. But it was an Amazon algorithm, and it was about two competitors looking and creating an algorithm on each other's pricing, which overnight resulted in a $23 million book. Quite fun. Good story behind. Probably a little bit less fun, $182 billion missed trade. So I believe the statistics were that only 0.03 of the trade were actually executed, but I probably think that maybe in that boardroom a few people had things to say about the data science team. We need to make sure that we're getting these things right. This is my favourite. Wiki edit bots engaging long-term feuds. So it was actually University of Oxford, and they tracked the behaviour of wiki edit bots from 2001 to 2010, also 13 different languages, and they discovered that bots engage in online feuds. And this is a really compelling story. So if you've got the time, have a look at this one. And I think the story here is, we need to be careful about the application of our models. And we need to have the right framework, and we're going to learn how our customers certainly do that. This is the last call out. I'm going to hand over actually to Krista next, but what I want to do is I want to call this out. Is Howard Dresner coined the term BI back in the early 80s, and the reason I thought I wanted to share this with the audience today was this isn't a software company like TIBCO saying we're great or this is cool. It's not an analyst firm saying, buy us. This is actually a survey from over 5,000 professional users applying data science and AI to real-life problems and driving innovation. And TIBCO came out ranked #1 for advanced analytics, advanced and predictive analytics. So we're very pleased with that. I wanted to call that out. It's very recent news, but also what we're seeing here is that this is actually users that are competing and winning, and they're voting for our tools. So this is a really nice thing to say. And at that moment, compete and win, and we're going to hand over now to Krista. Krista, I'm going to pass the ball to you, and Krista, over to you, and take it away.
Thank you very much, Alan. My screen should come through here any second. I hope you all can see it. So, PrecisePrediction, we are actually an international spin-off of Stats of Norway. We've been around since 2005, but the founders of the company have been working with data mining, predictive analytics, and machine learning a very, very long time. And our slogan is sort of that we make big data profitable for you, or even better, we make your data profitable for you. We have been working with big data and machine learning because before most people even heard of it. And over the years, we have delivered projects all the way from Australia to Canada, and of course, many projects back home here in Norway and the Nordics. We started to analyze. We received data on floppy disks, so you don't necessarily need a lot of big data. You can most often start to get profit out of the data that you already have in your organization. Historically, we have been working with a lot of bank and finance customers, but we see We see that we get a lot of requests from other industries as well. I'm not going to walk you through all of this. It will be, we'll probably share the presentation after so you can have a look at it yourself. But one of the cases that we are still working on is a tax authority, and it is to discover and prevent VAT fraud. And they want to have a more effective usage of their available resources to actually catch people or companies doing VAT fraud. And the benefit is that they want to have a higher hit rate, but when they have been doing this, they also got a lot of attention in media that tax authority are taking new machine learning models in place so the risk to getting caught is getting higher, and that also will have a very strong preventive effect. If you are thinking about it, doing something you shouldn't do, this will sort of be in the back of your head. So the tax authority in this case are using Statistica and machine learning to predict and prevent VAT fraud. They actually have access to a lot of data, maybe too much to handle sometimes. So we actually had to do what they called hyper-optimization of variables. I will take that in another webinar, but exactly what it is. And they are also using text mining from on-site controls. And we are converting that into predictors as well. And let us just take an example. Let us assume that one of the offices has a capacity.
Hi, Krista. Just to let you know, your line has gone very faint. If you could readjust your headset or just try something more in.
Better now, I hope.
No, it's not.
Should be now. So they have the capacity to do 50 checks a day, and instead of just doing random checks, they will let the machine learning models to decide who they should do a check on, and also what kind of control they should do to get the best accuracy of the checks. And that could be a phone call follow-up, it could be a mail or a letter, or in some cases also an on-site control. The result is that they increase the accuracy of all the checks, meaning they are catching more companies doing VAT fraud. Another case, which is also about to catch the bad guys, is how a police force can use machine learning to predict crime and improve their efficiency. And this is also about catching the bad guys. The challenge we got was to investigate how they can get better usage and more efficient use with the available resources, meaning not adding more police officers, don't add any more material like more cars or more equipment and things like that. And they also already had a lot of data and documentation available, so we didn't need a very huge project, and we could start with whatever they already had. We found, for example, a correlation between certain types of crimes. And if they could have a special investigator on site as soon as possible, they managed to sort of solve that crime and catch the bad guys much quicker compared to if the special investigator was connected to that or got it on his or her desk a couple of days later. The problem they had, though, was that the work schedule sort of said that that kind of special investigator usually didn't work at the time when the crime was committed or when they have a peak of that certain type of crime. So a direct result was that they changed the work schedule for a lot of people within the organization, with the result that they managed to solve that type of crime much more efficient and catch the bad guys much quicker. We also looked at, they have a lot of police car, patrolling cars driving around. So we sort of managed to predict where and what type of crime that was committed, for example, on a Saturday evening. So we helped them to change the route of the cars. So the police cars and the patrols were closer to where we predicted that it would be committed a crime, which also increased the efficiency of the police force. Next story, a Telco, a mobile operator that actually created a bank. And you can ask yourself, why should a mobile operator start to provide financial services? And when we looked at that, it was quite easy math. We don't even need predictive analytics or machine learning to predict that this will be a profitable operation for them. However, they are operating in countries where maybe only 10 to 20% have access to a bank or a bank account. But on the other side, 80 and even as high as 90% have access to some kind of mobile device. So it might not be a smartphone as we are used to up here in Western Europe or Europe overall. But it could be some what we call a legacy device that don't have Facebook, Google, or Apple integrated to the phone. But they do have a very strong and well-known brand. They have a direct access to a huge customer base, partly through their mobiles, of course, but they also have an established nationwide telecom agent where they are selling the phones and selling the subscriptions. So if you have a look, the same here, we didn't need to add any data. The telcos, they have a lot of data and a lot of behavior data of their customers. And they realized that the telco data is actually one of their most valuable assets. So the big challenge here was to monetize that asset. And they also, as I mentioned before, they also have a huge competitive advantage compared to traditional banks to reach out to the mass market. So our goal here was to convert data into credit insight. And as I said before, the goal is to monetize the asset they have. So let us compare two customers or two SIM cards because most of it is unregistered prepaid subscribers. So they don't necessarily know who the customer actually are. So we need to measure the behavior of the scorecard instead of the person, because in some of the countries they don't have things like we take for granted up here, like a social security number. It's quite easy for most of us to document our address, and you have credit bureau information from example Experian or others. So it's quite easy here to do your KYC, meaning know your customer, and document who is actually the owner of the phone or the SIM card. But let us compare two SIM cards. The first one is connected to a quite cheap handset. Could be an old or a cheap legacy phone. The usage is very limited, meaning they are generating a very small revenue for the telco operator. And we can also see that this SIM card is connected to the same base station more or less all day. The conclusion could be, in this case, that the owner of this SIM card does not have a job or a steady income. If you compare this to the second SIM card, it could be connected to a more modern phone, a smartphone. The usage is high. We can see that this person is topping up their prepaid subscription on regular basis and generating a high revenue to the telco operator. And we can also see regular movement. For example, this person is moving out from the regular base station every morning at 7:30. We can see that this person is connected to different base stations around the city, and then connected to one base station in the city center for 8 to 9 or 10 hours, and then take the same route back again. So the conclusion would be that the owner of SIM card number 2 probably have a job and a steady income. So if you were the telco and you could choose to offer some kind of credit to either SIM card 1 or SIM card 2, who would you choose? At least for this telco, they started to offer some small airtime credit to SIM card number 2, and then moved it on from there to also offer microloan credit, and they are also quite big on payment services in some of the countries they are and regions they are operating to. Then we have something quite exciting in our innovation team that we are working on. The end user or the customer here is coming both from construction, but we're also working with a mining customer. The main goal is to improve the security for the workforce, meaning the people on the working site or down into a mine. So let me present our connected intelligent helmet. As I said, this is still on innovation, but we are testing it out in the field, and we are getting really good data in to present this up into the dashboard. Another next thing we are doing together is the connected intelligent drone. We see that the drone market is increasing dramatically. we see that operators are using drones into more and more daily cases. It could be to inspect power grids, or in this case, also to improve the security of the workforce. And we are also looking at getting data from the drone itself. But let's start with our connected intelligent helmet. So we have equipped the helmet with a lot of sensors. So we are, for example, now able to live measure different kind of air quality, for example, VOC. We are measuring dust particles in the air that they are breathing in. We are measuring the CO2 level, temperature. We are getting the heart rate of the owner of the helmet, and the sound level. And we also have a 3- or 4-way vibration level. So, for example, we could measure if the helmet is lying down, if it's moving, the angle of the helmet. So what we have done is that we have collected all this data and sort of agreed with the customer in this case what we should call outliners. For example, if the helmet won't do anything, if the heart rate is within a normal range, or if the dust particles is within normal range, and the same with CO2 level. So we are collecting data, building machine learning models, and then deploying them back to the helmet. So we are making the helmet itself more intelligent and able to think for itself. And we also have a camera enabled on the helmet. So, for example, if the CO2 level is dramatically increasing, or if the heart rate is dramatically increasing or decreasing, that could trigger off the camera. And as you can imagine, if the camera shows something like this, as you can see in the right down corner, you really have an emergency and need to take some serious action. The idea with the drone is pretty much the same. We are connecting it to the same type of dashboard. And the idea here is to let the drone, send the drone in first to control that the environment that they want to have people into is safe and secure. And we are also using the built-in camera into the drone. What's quite funny when it comes to the drones, that we see that a lot of manufacturing are actually adding computer power to the drone directly. So in this case, we actually don't need to add any computing power. That is already built in from the vendor that we are working with. What we are doing, though, in this proof of concept is adding different kind of sensors. And one important use case here as well is the predictive maintenance of the drone itself. And at the moment, we are doing that by measuring the vibration from the drone. So during normal operation, we know how the signature of the vibration looks like. And if that change, that could be because of one of the turbines is getting damaged or something. The drone itself will return to base and request maintenance. And as I said, we also let the drone to be a carrier of different sensors to measure and measure the quality, in this case air quality, before they send people into a mine or to a construction site. That was pretty much it from me. So with that, I will hand it over to Heleen again.
Great, thank you very much, Christopher. So the customer stories that I have chosen to today represent, as Alan said, different continents and also different industries. And these TIBCO customers have generously shared their data science experience for broader learning purposes, so we're very grateful to that. The first story is about Vestas. Vestas Wind Systems is a wind power market leader. They have built 57,000 wind turbines in 75 countries, and they service about 33,000 of those. And all of these turbines are generating a lot of power, but also a lot of data, and importantly, $8 billion of revenue every year. So Kim Emil Anderson heads the advanced analytics team at Vestas, and his team has really contributed to Vestas' success by providing the various data assets and knowledge and understanding of it, as well as analytical capabilities to the company. And it's safe to say that Vestas is a big data company. Each wind turbine has about 1,000 sensors, and they generate a data point every 10 minutes, or each sensor generates a data point every 10 minutes, or sometimes even every second. And an average of 30 gigabytes of data is collected every day. They also have a big climate library, several petabytes in size. It contains 16 years of historical weather data for each section of a 3-kilometer grid of the Earth. And from that data, they actually model climatic conditions for any part of the globe. And as you can see on the slide, they also collect various other data sources, either related to Vestas operations or external data, such as the electricity prices. And in order to manage all this data, the Vestas data environment actually features a supercomputer with more than 8,000 cores and an incredibly fast connection between nodes. Now, no worries, you don't need a supercomputer in order to do data science, but for the data volumes that Vestas manages, it is necessary. So Vestas has developed dozens of high-value analytic applications, with some examples here on the slide. The first one, for example, software rollout, maps out the software versions customers have installed on their turbines, and it provides a justification to upgrade to the latest version. Another use case that I always like is number 4. It's about a predictive maintenance application for de-icing. So it helps avoid breakdown of turbines, because you get some alerts when some of the blades get iced up in winter. But today I'll actually go into the second use case of availability simulator in a bit more detail. So to help you understand what that use case is Vestas has service teams that service all of these wind turbines for the customers. And when they review contracts or when they make new service contracts, they often need to know the risk of not being able to fulfill the contractual obligations. And that answer requires a risk calculation traditionally done on the supercomputer by an experienced data scientist. However, today, by making a user-friendly analytic application, Vestas allows the people in front lines to calculate and understand the risk. So this is, on this slide, you actually see an overview, a simplified overview of the architecture for this application. Turbine data comes into an SQL server setup, a data warehouse. In addition, there is enterprise resource planning data coming from an SAP system. This data is combined in the supercomputer, which makes it available for running sophisticated analysis using Spotfire and R. And in this application, Vestas is analyzing maybe 15 or 20 million rows of data to calculate its risk. So this is a screenshot of the application that the users actually see. So all of the complexity is hidden behind the easy drop-down menus. In this example, the confidential data is grayed out. So in sort of the day-to-day business, if one of Vestas clients asks for a certain threshold or a certain availability guarantee, the service team is actually able to use this application to figure out what that would mean for their operations. And the benefit is that the global service team can run this anytime, anywhere, and is not dependent anymore on a specialist data team in Denmark, which is actually where the data science team is based. So this is a really good example of data democratization. And Vestas attributes high value to many of their analytic applications, and they now have many different users outside of the data science team benefiting from advanced analytics. An example of these new users are engineers, salespeople, product managers, and analysts. So the next story is one from the University of Chicago Medicine. They're one of the U.S. Leading academic medical centers, established in 1927. They have 9,000 employees and 806, to be exact, licensed beds. And their chief enterprise architect, Kristen Watts, explained to us how, for them, a big driver to change in healthcare in general and for their hospital specifically is a move from a transactional to a much more value-based business. And this is actually very similar to what we see in other sectors. For them, it's both the patients as well as regulators driving this change. So they first needed to be able to share data across a large number of disparate systems, and they needed to break down technology as well as functional silos to achieve that. But once this was established, they could start measuring and improving the care they're delivering, and specifically reducing the number of cardiac arrests. So what did they do? They actually implemented a solution that uses streaming analytics and an algorithm developed by one of their leading researchers. They use historic patient data, data from patient monitoring equipment, and are able to alert their rapid response team to go to the bedside of the specific patient who is determined to be at high risk of going into cardiac arrest. And notably, when they first installed the system in 2015 at 7 a.m. in the morning, by 10 a.m. they had already prevented their first cardiac arrest. And since then, they have successfully reduced the number of cardiac arrests in the hospital by an estimated 15 to 20%. And not only that, they've also greatly improved operating room efficiency. They actually run 24 operating rooms concurrently. They have improved handoffs between the various stages of the operating process, alerting teams to upcoming events via text or pagers. There's a lot of different teams involved. You know, besides the doctors, you have people monitoring equipment and specialist cleaning teams. And they can anticipate on delays and show real-time dashboards of the operating rooms. And with that, they also managed to increase capacity and have an anticipated cost saving of up to $600,000 a year in operating margins. So I'd like to share one more similar healthcare example. This is from the University of Iowa Hospitals and Clinics, and another, I think, terrific story from a highly regarded academic institution. Their director of gastrointestinal surgery, John Cromwell, shared with us how they have modeled a complicated workflow of the surgery process. So the end result for them was quite revolutionary. By combining electronic medical records patient data and real-time operating room data for the patients who are undergoing surgery, and by deploying the model they developed, they're able to recommend changes to the OR procedures in real time. And this has resulted in a reduction of surgical site infections by 58%. And as you can see, you know, with an estimated cost for this nationally in the US of $10 billion a year, this has a huge value implication. And not only, you know, to reduce costs, but obviously also to improve patient care and avoid complications in recovery. So on to a whole different use case. This is one from our customers, one of our customers in Asia, KB in South Korea, and it's a great example of applying data science to customer marketing and customer data or customer experience. So KB is a subsidiary of KB Financial Group, and they're responsible for banking, securities, insurance, and credit cards. They have $15 billion in assets and 19 million cardholders. And Jae-hoon Park is the head of the company's Big Data Strategy Center. He presented this story at a recent TIBCO Now conference in Singapore. And when he started his presentation, he first painted the picture of the Korean market with credit card charges totaling almost 80% of family expenditures, so a lot of small expenditures in that. I think he mentioned that 40 or more than 40% was less than $9 per charge. They also have a very fierce competition with 22 credit card companies that they're competing with. Their goals are all around customer satisfaction and customer experience, and they decided to really invest in technology and the process for their campaign systems, which was at the time, sending out very generic and non-specific offers likely perceived as spam by their customers. So we helped them set up a real-time marketing platform, which was aligned with their marketing goals, and they named it the Smart Offering System. They use machine learning to analyze historical customer data and create personalized algorithms and models. They also managed to expand and also automate the number of campaign scenarios they can run simultaneously from 30 when they started to 300 when they finished. And this significantly improved customer satisfaction because of the targeted offers and also improved acceptance rates. Being able to monitor these acceptance rates in real time and being able to analyze and understand the behaviors of the customers were, according to them, significant factors in achieving an increased sales rate of $600 million a year. So today, they understand where and when and why their customers use their cards, and they can act on that knowledge in real time. Mr. Park has estimated that they are actually 5 years ahead of competition now when it comes to their marketing capabilities, so that's a really significant achievement. And last but not least, the team at KB Cookman Card has also become much less dependent on IT. So the marketeers feel much more empowered to use their creativity to design campaigns directly, and it has resulted in a much improved job satisfaction. So that's a nice additional benefit as well. Now, as this webinar series is all about competing and winning with data science, it would only be appropriate to also talk to you about some details of the TIBCO and Mercedes-AMG Petronas Motorsport Global Partnership. So Mercedes-AMG Petronas Motorsport is one of the leading teams in Formula One, as you may have seen last weekend with the race in Austin and Lewis Hamilton finishing first. They, over the years have built a good competitive advantage by working, on excellent engineering and hiring the best drivers. But to sustain their competitive advantage, we're very pleased that they have now decided to partner with TIBCO software. And as you can imagine, we have a lot of people and experts within TIBCO that are very excited to be working with them on their projects to help them win. And this is definitely a big data landscape. So just to give you an idea, every car has about 200 to 300 sensors. I learned by studying this in a bit more detail that 11 of those are actually in each tire. They collect 300 gigabytes of data per car per race weekend, and a lot of contextual data from the race as well, a total of 45 terabytes of data each week. And the type of analytic projects that benefit the team involve analyzing historic race data, test data to improve the setup for every next race, but also monitoring performance during the race and improving decision-making on race strategy as well as equipment setup in real time. For example, with more accurate predictions of how quickly components are wearing, like tires, they know whether a pit stop is due or not. They also plan to compare pre-race simulations using Monte Carlo simulations to create race predictions using the team's performance data during the race. And thanks to detailed data available on each part of the car, they can also inform future car design improvements. So I really recommend that if you can find the opportunity to listen to Matt Harris. He's the head of IT at Mercedes-AMG Petronas Motorsport. It's fascinating to hear him speak about the constant race against time. 1,000th of a second can mean winning a race. They also have a limited number of hours to set up and break down their IT equipment at race location, which is different every time. Can be moist, a lot of moisture or sand, or have a lot of different environments to deal with. They also only have 90 minutes between practice and qualifying rounds to get the data from the car, to analyze it and also instruct the mechanics on possible adjustments to make. Matt Harris will actually present this week at our TIBCO Now conference in San Diego, but he will also be a keynote speaker at an upcoming big data event in London on November 15th and 16th. So, through these type of events and our various blogs and YouTube videos and webinars, we try to keep you up to date of our partnership and some of the analytic projects that we're working on. And on this, I'd like to close off this story at least with showing a quote from Toto Wolff. He is head of Mercedes-Benz Motorsport and comments on how data provides them with a competitive edge, being able to make quick decisions based on sound information and also judgments, of course, from his expert team. And in his words, he says, working with the TIBCO enables us to optimize our performance and benefiting not only our strategic decisions at the racetrack, but also how we operate back at the factory, which is where, a big part of their team is working to make these races so successful. So this brings us to our final section on the TIBCO community, which will be brief. Just maybe a reminder for everyone to submit your questions through the Q&A or chat if you prefer. We'll get to those in a few minutes. Ellen already mentioned this, but we do have a very useful resource for all of our software users. It's called the TIBCO community. You'll find partner information there, lots of tips and tricks on how to use our software. If you're just beginning with data science or you're making next steps in data science, you'll find lots of helpful tips there. Also templates to download. There's a forum where you can ask questions, and you can also download files for any of the software that we've presented in this series. We also actually created a page specifically for this webinar series. This is mainly used by the data scientists who are now doing the hands-on exercises and sort of trialing our software. You can post questions. We will respond to those. If you are looking for the recordings or any of the slides, we'll post those here as well, and any other relevant links that might be useful for you. But this brings us to the end of the webinar. To wrap up, we've shown you, I think, in this series and again today, that TIBCO is a one-stop shop for actionable insights. We provided you with lots of examples and evidence today of the value that data science can deliver to your organization. And it doesn't matter whether you're building more compelling customer experience or whether you want to improve certain aspects of your operations, if you want to reduce risk, the principles of deploying data science and AI are all the same. We've seen that you start with learning from your historic data. You then build a model that fits your data, but also your business problem. You then apply the model in batch or in real time, depending on your business situation and your data availability, to predict what's happening next. And then you augment the intelligence in your organization with either decision support or automated actions. And then it's also important to monitor and improve the model and performance over time. And most importantly, you also are enjoying a competitive advantage. So with that, we're going to do questions and answers. Ellen, I hope that you have been monitoring the questions that have come in.
Yeah, thank you. Thanks, Heleen, and thanks, Krista. I watched those practice sessions, but even seeing those again and bringing them to life was very cool. My favourite, as I said, I like the Stonework project from Precise, and I also really enjoy a bit of Formula One as well, and really on theme. So thank you very much to our presenters today. So I want to throw this out. I think the first thing I'll say is that we have more people at the end of the webinar than we did at the start, which is fantastic. It means that everyone else is engaged and certainly not bored. We'd like to throw this out for questions. I've got a couple of early ones, but and I've got some really interesting questions actually coming in. But if anyone else has any thoughts or questions or queries, please start to bring those in, and we can look at those in the question and answer panel. So I've actually got one for Heleen, and this is for Mario. I have a question about the Vestas case study. Can you expand a little bit on the software upgrade use case?
Yes, so the software upgrade use case, as I mentioned, it was to sort of monitor what turbines are using what software upgrades or what software version. Vestas is really a data company more than a turbine company. Part of their competitive advantage is that they can deliver their customers with a better understanding of how the turbines work than any other company because of their analysis of the data. And they apply that data to new versions of software, so that the software that operates the turbine takes advantage of the knowledge that they've gathered on the process. So it's to the benefit of the customers and Vestas that the latest versions of software is installed, And they sort of discovered this by coincidence that they were expecting that all of the customers were using the last versions, but they weren't. And once they had that mapped out, they started to analyze the performance of the turbines that were on an old version versus a new version, and they could prove that there was a big benefit in yield if you would upgrade to the latest version. So that specific piece of data really helped their customers with encouraging them to upgrade. And sometimes there were just technical issues for not upgrading that they needed a bit of help with, and doing that has really increased total yield and a big sales increase or profitability increase for Vestas and their customers as well. So hopefully that provides a bit more detail.
Sure. Heleen, thank you. Heleen, I've got another one, I think, for you more than Krista, actually. I downloaded the trial software, and I'm going through the hands-on exercises from last week. Thank you for your time last week, but I need a bit of help. Can I get some support?
Yes, so this question actually I think came in before I showed the TIBCO community. So just going back to that slide, the TIBCO community is available for everyone. You can just register for free if you're using our software. And we created this page especially for you and others trying out the software. So if you have any questions, as you can see actually on this slide, you see the answer section. The answer section of the community is there to ask questions and for us to give you answers, but also for your peers and other enthusiasts to answer your questions. So if you use the tag compete and win, or if you include the webinar series title or the webinar series link or this page link, our support team will be very quick to respond to you and probably pass on the questions to our data science team, my team actually, to help you. So we're looking forward to many of you asking for some support and should be responding to your questions via the community very quickly.
Thank you, Lee. I've got one for our Stig over in Norway on top of his mountain. So over to you, Krista. How do you recommend I get started with data science in my company? What projects should I prioritize to take to the board?
It totally depends on what kind of company you are, but as I said in my presentation, we prefer to start quite small with the data you already have, and it needs to be a project where you can actually take decision based on your data, a data-driven decision. But that could be within predictive maintenance. Back home here in the Nordics, we are, for example, working a lot with different banks. For example, Danske Bank, BN Bank, or Ekqvist Group, or others. And that is very much about improving the credit score capacity. For example, we have some in-house developed algorithms that have a much higher performance compared to the industry standard. So what we actually are doing is that we are using their historical data, historical customer behavior data, and are building more accurate credit scorecards out of that.
Krista, thank you very much. I'm going to throw this back to you, Krista, again. Heleen's already had two, so on that note, can you give an example of challenges your customers had to overcome? Anything that stands out?
Data is always a challenge, and there's a lot of buzzwords going around there, like big data, and they all want to integrate that to be, for example, social media data, things like that, and that will loop us back to start small, start with what you have, because you will get a lot of information and a lot of, should we say, increased efficiency and increased profit out of the data that you already have. So just let us in, let us have a couple of workshops, and we will, our findings in your data will give you better insight of your own company and your own customer portfolio or machines or whatever you have.
Okay. Krista, thank you very much. We're going to finish on this one. We're going to give everyone a couple of minutes back in their day, but we're going to finish on this one, which is, can I deliver a project, or Heleen, can you help with a project in Italy?
Yes. So we're not bound by any region. So, you know, it doesn't really matter where you're located. We can help you with any data science projects. I also noticed, Ellen, I think at this point, can you read that question that came in about? Yes. So there was a question. Sorry, is it okay if I answer one more question?
Yeah, cool.
And any other questions, we'll also be answering those offline with you. So there was a question about somebody who has created some optimization models in Python for allocating resources to locations, and it requires a data science team to operate. Can Spotfire help develop the front end? And then a few more pieces of the question. So Spotfire can certainly help to develop a front end. For Python, actually, Statistica may be the better option. So we have an analytics portfolio that really meets sort of the favorite tools and languages of any of the data scientists. So we'll follow up with you and help you develop that front end. But I think the question is spot on, because that's exactly what we're trying to do, is make data science more accessible to business users and create those nice, easy-to-use dashboards, whether it is through Statistica or through Spotfire. So looking forward to following up with you on that question.
So on that note, we'll bring today's series to a conclusion. A reminder that you've got all of those resources, the wiki pages, community pages, series landing pages, and we're going to get a recording of today's webinar out to you. If we have any more questions, feel free to reach out to any of the panelists today, but we really thank you for your time today and hope that your day continues to be excellent.